So, hi everyone. So, good evening all. So, first of all, let me know whether audio and video everything is clear. So, first of all, let me know whether audio and video everything is clear. See, if it is not clear, please let me know through chat box here. Please comment something in chat box if it is not clear. Right? Okay. So, I hope everything is clear. I hope everything is clear. Right? Okay. So, we are solving the problems here. We are solving the problems in the topic of uniform plane waves. We have solved the problems in case of lossless medium, and also we are solving the problems now in case of lossy medium. So, today also we try to solve some different types of problems here. Right? Okay. Okay. So, let us write down the first question. Let us write down the first question for today. Write down here. So, the first one. So, write down the question. So, for seawater, see, we have analyzed the skin depths at different frequencies in case of seawater. Yes or no? And also we have seen in the previous class that for submarine communication we prefer what? We prefer low frequency signals. So, what is the reason and all those things we have seen in the previous class itself, right? Okay. Okay. So, for seawater, what are the properties here? So, the conductivity is equal to 4 7 per meter, and then epsilon r, relative permittivity, is equal to 80, and relative permeability mu r is equal to 1, right? So, so for seawater, these are the properties of the seawater. That is, conductivity of seawater is 4 7 per meter, relative permittivity is 80, and relative permeability is equal to 1. So, then they are asking, what is the distance? What is the distance? So, you have to write along with me here, right? So, what is the distance for which radio signal can be transmitted with 90% attenuation, at 25 kHz, right? So, this is A. Next, B, determine propagation constant. Right? So, next, C, determine skin depth. Right? Okay. Right. So, this is the problem they have given. So, see here, what is the problem here? See, so you have to write down along with me here. You have to write down the problem, right? So, see here, what they have given for seawater. For seawater, conductivity is equal to 4 7 per meter. Epsilon r, relative permittivity, is equal to 80, and relative permeability value is equal to 1. Then question number A. So, that is what they are asking here is what is the distance for which radio signal can be transmitted with 90% attenuation at 25 kHz. Okay. In B, they are asking to determine the propagation constant. In C, they are asking to determine the skin depth. Right? Okay. So, first of all, concentrate on A. Right? So, here what they are asking, what is the distance here? What is the distance for which radio signal can be transmitted with 90% attenuation at 25 kHz, right? Okay. So, now here they have given So, they have given conductivity is equal to 47 per meter, and epsilon r is equal to 80, and then mu r is equal to 1, and at frequency f is equal to what? F is equal to 25 kilohertz, right? Okay, so at this frequency the radio signal is transmitted in seawater. So they are asking what is the distance it has to travel. What is the distance? What they are asking, what is the distance for which this signal can be transmitted with 90% attenuation here. It has to be transmitted with 90% attenuation. So that means by the time the signal reaches to the target, it has to be attenuated. It has to be attenuated to 90%. Yes or no? Okay, so that means 90% of the signal is getting attenuated. So now after traveling some distance, 90% of the signal is attenuated. So that means what is left out here? What is left out? Only 10% of the signal is left out. Understood? See, we know that since here the conductivity of the medium is not equal to 0, we can say the medium is going to behave as lossy medium. Right. So the medium is going to behave as lossy medium. So in a lossy medium, whenever the wave is propagating in a lossy medium here, what happens? Its amplitude is going to decay. Yes or no? So let us consider the amplitude of the electric field of an electromagnetic wave. So let us say the amplitude of the electric field of an electromagnetic wave. So that is E naught into, okay, or otherwise I can solve in this manner here. So okay, so let us say this is sea water here, this medium is sea water, right? Okay, so now let us consider this is z axis and let us consider this is 0, right? So initially, so here I am representing electric field of uniform plane wave, right? Okay, so this sea water is acting as what? It is going to act as lossy medium. Why it is going to act as lossy medium? Because the conductivity of the medium is not equal to 0. Yes or no? What is the condition for lossless medium? The condition for lossless medium is conductivity must be equal to 0, epsilon r and mu r values must be real quantities. Here epsilon r and mu r values are real, but conductivity is not equal to 0, and hence this medium is going to behave as lossy medium. And we know that whenever the wave is propagating in a lossy medium, its amplitude is going to decay exponentially. Yes or no? Okay, so let us say I am considering the electric field of the electromagnetic wave. So as it propagates in this medium, what will happen here? Its amplitude is going to decay. Exponentially. So the exponential decay, I can represent it as what? E naught into e power minus alpha z. So where E naught is nothing but the initial amplitude. Let us say at this location z is equal to 0. At this location, let us say the initial amplitude is E naught. Right? Okay, yeah. So now here what they are asking a radio signal, what is the distance traveled by a radio signal? What is the distance traveled by a radio signal? What is the distance for what they are asking here? What is the distance for which radio signal can be transmitted with 90% attenuation? Understood? So let us say it has traveled a distance. Z meters here. Let us say it has traveled a distance z meters. So this distance is z meters. Let us say, right? So after traveling a distance of z meters, let us say it is attenuated 90%. So 90% of the signal is attenuated. So that means what is the signal that is left out? Only 10% of the signal is left out. So that means at this location here, what must be the amplitude? Amplitude will become 90% is attenuated, so only 10% of the initial amplitude will be left out. So that means at this location, what you are going to have? The amplitude will be 0.1 times of what? E naught. Yes or no? Now they are asking to determine this z value. Right. So during this distance, how much of the amplitude is attenuated here? So 90% here. 90% of the signal is getting attenuated. right? So after 90% getting attenuated, what is left out? Only 10% of the signal is left out. So the 10% of the signal is nothing but 0.1 times of E naught, right? Okay, yeah. So after traveling Z meters, so I can write after traveling Z meters here, after traveling Z meters, okay. So the amplitude E naught into e power minus alpha z will become what? Will become equivalent to what? After traveling Z meters, amplitude has become 0.1 times of E naught, right? Now we have to determine what? We have to determine this Z value, right? Okay, yeah. So after traveling Z meters, the signal has attenuated 90%. So that means only 10% of the signal is left out, right? Okay. So that means 0.1 E naught, right? So now see here, so here E naught will get cancelled. So then you are going to get e power minus alpha z is equal to 0.1. So now if I apply ln on both sides here, so ln of e power minus alpha z is equal to what? Ln of 0.1. So here you are going to get minus alpha z is equal to what? Ln of 0.1 is how much here? I think 2.3 something, right? So ln of 0.1, so minus 2.302, right? So we want to determine what? Z value, yes or no? So this minus will get cancelled. So therefore z is equal to what? Z is equal to 2.302 divided by what? Divided by alpha. So 1 by alpha is nothing but what? Skin depth or not? 1 by alpha is nothing but what? Skin depth. So I can write the same thing as 2.302 into what? Into delta. So this delta is nothing but skin depth. So we know that delta is equal to what? Delta is equal to 1 by alpha. Okay. So if you determine the skin depth or you can determine the alpha, then you can determine what? This Z value, right? Okay. So how you have to determine the skin depth? See here, in order to determine the skin depth, we have to determine the nature of the medium, yes or no? So for different medium, the skin depth is going to be different, right? So first of all, you have to determine the nature of the medium. So what is the nature of the medium here? Tell me, what is the nature of the medium? So in order to determine the nature of the medium, you have to determine sigma by omega epsilon ratio. So what is sigma by omega epsilon ratio? So this is equal to, so sigma value is 4 Siemen per meter divided by omega is nothing but 2 pi into f. F value is how much here? 25 kilohertz. So 25 into 10 power 3. So this is f value. So into epsilon is nothing but epsilon naught into epsilon r. Epsilon naught value is 1 by 36 pi into 10 to the power of minus 9. Epsilon r value is 8. Okay. So now what you are going to get? See here, there is no need to do all these things here. Yesterday in the previous class itself, we have seen for seawater here. For seawater, sigma equal to 4 Siemen per meter, epsilon r equal to 80, mu r equal to 1. So for this value, so what is the maximum frequency? Below which the medium is going to behave as good conducting medium? What is the maximum frequency we got here? In the previous session we have seen, that is 90 megahertz. So if the frequency is less than 90 megahertz, then the medium is going to behave as what? That is, the seawater is going to behave as good conducting medium, right? Okay. So that means without solving this, we can say that the medium is good conducting medium. Understood? So or else, if you want, if you are having any doubt, we can determine this value, no problem, right? So it is very simple. So here 2 pi 1s and here 2 pi 18s, right? Okay. So next, here 4 1s and here 4 20s, right? And here 2 9s and here 2 10s. So what is left out here? You are going to get 9 divided by 25 into, so here 10 power 3 and here 10 power minus 3 will get cancelled. So 10 power minus 6, right? Okay, so 10 power minus 6 here and here 10. So you will get 10 power minus 5 here. So 25 into 10 power minus 5. So 9 divided by 25 into 10 power minus 5. So this is equal to what? This is equal to, so obviously it is very much greater than 1 only, right? So 9 by 25 is 0.36 into 10 to the power of 5. Okay. Okay. So this value 0.36 into 10 to the power of 5 is far greater than 1. You can easily check that this sigma by omega epsilon ratio here. This sigma by omega epsilon ratio will be greater than what? It is going to be greater than 10. Yes or no? 0.36 into 10 to the power of 5 value is very much greater than 10. So we can say that the medium is going to behave as what? The medium is going to behave as good conducting medium. Right? Okay. Okay, yeah. So since the medium is behaving as good conducting medium, what is the formula for skin depth here in a good conducting medium? So in a good conducting medium, the skin depth is nothing but what? Delta is equal to 1 by square root of pi f mu sigma. Right? Now just substitute these values here. You are going to get skin depth. So that is 1 by square root of pi into f is 25 kilohertz, that is 25 into 10 power 3 into mu is mu naught into mu r. Mu naught value is 4 pi into 10 to the power of minus 7. Mu r value is 1, right? And sigma value is 4. So determine these values here. Determine this. So what you are going to get? So here 4 pi, right? Here 4 into pi. So 4 pi into 4 pi under root. So I can take 4 pi outside. So you are going to get 4 pi. Yes or no here? Okay. Next here square root of 25 is 5. Next here 10 power 3 and here 10 power minus 7. That means here you are going to have 10 power minus 4 under root. So that is you are going to get 10 power minus 2. Okay. Okay. So this is the value. So 4 pi into 5. So you are going to get 1.5915 meters, right? So this is the skin depth you are going to get. So if there is any calculation mistake, please check here. Please check that and let me know if there is any calculation mistake, right? Okay. So skin depth is 1.5915 meter. Okay. So now they are asking what? They are asking Z value. You have to determine Z value, yes or no? So that is this one. You have to determine this Z value. So Z is equal to what? 2.302 into delta, right? So therefore Z is equal to what? Z is equal to 2.302 into delta, which is equal to what? 2.302 into 1.5915. So this is equal to what? So this is equal to 1.5915 into 2.302. So you are going to get 3.66 meters. Okay. So Z is equal to what? Z is equal to 3.66 meters. So the signal after traveling a distance of 3.66 meters, the amplitude will be reduced to what? 90% here. Amplitude will be reduced by 90%. Understood? Okay. So 90% of the signal will get attenuated after traveling a distance of 3.66 meters. Right? Okay. Okay. Yeah. So for this question, what is the answer here? So for this first question, so for this A, what is the answer? 3.66 meters. Right? So for this question A, we got 3.66 meters. So after traveling a distance of 3.66 meters, its signal will be attenuated by 90%. Right? Okay. So next in B, what they are asking here? Determine the propagation constant. Determine the propagation constant. So how to determine the propagation constant here? So propagation constant gamma is equal to what? Propagation constant gamma is equal to alpha plus j beta, propagation constant gamma is equal to alpha plus j beta. So already since we have determined skin depth value, we can determine easily alpha value. So alpha is equal to what? Alpha is equal to 1 by delta, right? So what is skin depth we got? So skin depth is 1.5915. So 1 divided by 1.5915. So this is equal to, so what you are going to get? 1 divided by 1.5915. Okay, so you are going to get 0.628 here, 0.628 Nepper per meter. So this is the value of alpha, right? Okay. So next, what is the value of beta here? What is the value of beta? How you can determine the value of beta? Tell me. See here, we know that the medium is behaving as what? We have already determined that the medium is behaving as good conducting medium. Yes or no? The medium is behaving as good conducting medium. So in a good conducting medium, what is the expression for alpha? Alpha is equal to square root of what? Omega mu sigma by 2, which is nothing but what? Square root of pi f mu sigma. And beta value also what? Beta value is also square root of what? Square root of pi f mu sigma only. Yes or no? So in a good conducting medium here, in a good conducting medium, alpha value and beta value both are what? Both are same. Yes or no? The expression for alpha and beta is same in case of good conducting good conducting medium. So which means the beta value here is also equal to what? Same as alpha value, that is 0.628 radian per meter. Okay, so this is beta value and that is alpha value. So therefore gamma is equal to alpha is 0.628 plus j into 0.628 meter inverse. So these are the units of gamma, right? Okay, so this is the propagation constant, right? Okay. So next in C, what they are asking, determine skin depth. Already we have determined the skin depth, yes or no? So we already determined the skin depth, so that is 1.5915, yes or no? We got 1.5915. And here we have determined gamma value, propagation constant, right? So what we got? 0.628. So 0.628 plus j 0.628 meter inverse. Okay. So we have determined propagation constant, we have determined the skin depth, and also we have determined the distance the signal, radio signal has propagated with attenuation of what? 90%, right? Okay, at frequency 25 kHz. Okay, so with this we have completed this problem here, right? So write down next problem here, write down next problem. So second problem here, the amplitude of a wave traveling through a lossy non-magnetic medium, reduces by 18%, every meter, reduces by 18% every meter. So for 1 meter or for every meter, the amplitude will be reduces by what? Reduces by 18%, right? Okay. If the wave operates, if the wave operates at 10 megahertz, if the wave operates at 10 megahertz and electric field leads the H field, electric fields leads the H field by 24 degrees, then calculate a propagation constant. See, I have taken this problem from Sadiku here. So exercise problem I have taken, right? Okay. So propagation constant, not example problem here, it is exercise problem, back side of the chapter. Yes or no? Okay. So propagation constant. Next, B, the wavelength, and C, the skin depth, and D, conductivity of the medium, D, conductivity of the medium. Right? Okay. So these are the things they have asked to determine. Right. So write down the problem and you have to try on your own here. So write down the problem and try on your own. Okay. Okay. So see here, what they have given here, the amplitude of a wave traveling through a lossy non-magnetic medium reduces by 18% for every meter, for every meter. If the wave operates at 10 megahertz, the operating frequency they have given as 10 megahertz, and electric field leads the H field by 24 degrees, then calculate the propagation constant. A is propagation constant, B you have to calculate wavelength, C you have to calculate skin depth, and D you have to calculate conductivity of the medium. Right? Okay. So first let us calculate propagation constant. So A, we'll try to determine propagation constant. Right? See, if you determine propagation constant, remaining all things are going to be very simple here. So propagation constant, gamma is equal to what? Gamma is equal to alpha plus J beta meter inverse. Right? So you have to determine alpha value and beta value. Right? So what is the question they have given? The amplitude of the wave reduces by 18% for every meter here. So here the frequency of the wave here, the frequency of the wave they have given as 10 megahertz, and they are saying that amplitude of the wave reduces by what? Reduces by 18% for every meter. Right? Okay. So see here, if I consider this medium here, right? See, the amplitude is reducing means what? The amplitude is reducing means the wave is propagating in a lossy medium. So here let us say this is some lossy medium. Right? Okay. Okay. So let us consider it is propagating along z direction. You can consider anything here. You can consider x direction, y direction, whatever you want you can consider, but I am considering here z direction. So here I am considering the electric field here, the electric field of an uniform plane wave. Right? So let us say this is at z equal to 0. So at this location let us say the amplitude I am considering it as E0. right? Now as the wave propagates in this medium, what will happen here? The amplitude is going to decay as what? The amplitude is going to decay exponentially, yes or no? So as it propagates in this medium, the amplitude is going to decay exponentially like this, right? Okay, okay. So it is going to decay exponentially like this, E naught into e power minus alpha z. Okay, so what they are saying here, it reduces by 18% for every meter. So it reduces by 18% for every meter. So that means for every meter, the amplitude will be reduced by 18%. The amplitude will be reduced by 18%. So 18% is reduced means what is going to left out here? 82% of the amplitude will be left out. Yes or no? Okay. See, let us consider, let us say the initial amplitude is E naught. Let us say the initial amplitude. This is initial amplitude, right? So let us say the initial amplitude I am considering as E naught. So after traveling a distance of 1 meter here, so let us say this distance is 1 meter. So after traveling a distance of 1 meter, okay, after traveling a distance of 1 meter, so its amplitude is reduces by 18%. Yes or no? So 18% will be reduced for 1 meter. So which means 18% is reduced means what is left out here? 82% of the initial amplitude will be left out. So that means after traveling 1 meter distance, what must be the amplitude of the wave? The amplitude of the wave must be what? Must be 82% of initial amplitude. So that is nothing but what? 0.82 times of what? E naught. Yes or no? So this is nothing but 82% of what? 82% of E naught. Why? Because 18% will get reduced. Okay. Kishore Selvaraj. Yes, very good here, very good. Okay. So that means here after 1 meter here, so at z equal to 1 meter, okay, so after traveling 1 meter distance, what is the amplitude? So the amplitude E naught into e power minus alpha into what? Z value is 1 meter. So is equal to what? After traveling 1 meter distance, its amplitude will become what? 0.82 times of what? 82 times of E naught. Yes or no? So here E naught will get cancelled. So therefore you are going to get e power minus alpha, z value is 1, right, is equal to 0.82. So now if you apply ln on both sides, you are going to get minus alpha is equal to ln of 0.82, right? Okay. So what is ln of 0.82 here? Is nothing but minus 0.198, right? This is alpha. So therefore alpha value is equal to what? Is equal to 0.198 Nepper per meter. Okay. So this is the value of alpha, right? So we have determined alpha value here. So next you have to determine beta value. So Selvaraj, okay, very good here. So 0.198 approximately, 0.19845, okay, okay, no problem. So 0.198 Nepper per meter. So this is alpha value. Now how we have to determine beta value here? We have to determine what? Propagation constant. So we have determined alpha value. Now how you have to determine beta value? How you have to determine beta value? Tell me, how we can determine the beta value? Tell me here. Tell me. See here, they have given here what? They have given that electric field leads H field by how much here? 24 degrees. The electric field leads H field by 24 degrees, right? Okay, yeah. So now from that here, from that. So I'm clicking next page. So they have given that electric field leads H field by how much? By 24 degrees, right? So that means E by H ratio here, E by H ratio is nothing but what? Is nothing but intrinsic impedance of the medium. So since this medium is lossy medium, I am writing eta lossy. This is equal to what? This is equal to, it is going to have magnitude as well as what? As well as phase shift. Right. So the time phase shift between electric field and magnetic field, they have given us what? They have given this phi lossy as 24 degrees. Right. Now we know the expression for this phi lossy here. Already we have derived this one. Yes or no? So what is the expression for phi lossy? So the expression for phi lossy is equal to what? Is equal to 45 degrees minus tan inverse of what? Tan inverse of omega epsilon by sigma divided by 2. Okay, so this value they have given it as 24 degrees. So from here you can determine what? From here you can determine sigma by omega epsilon ratio. So once you determine sigma by omega epsilon ratio, then we can determine beta value. Right? Okay. Yeah. Yes, very good, very good. Okay. So what you are going to get? So 45 minus 24 into 2 is equal to what? Is equal to tan inverse of omega epsilon by sigma. Okay. Okay. So therefore what you are going to get? 45 minus 24 into 2, right? 42. So tan 42, right? Okay, so you are going to get omega epsilon by sigma as a 0.9 here, 0.9, right? So 1 divided by answer. So sigma by omega epsilon ratio will be 1.11, 1.1106. So you can write simply 1.11. So sigma by omega epsilon ratio is 1.11, right? Okay. See here, sigma by omega epsilon ratio, we got it as 1.11. So that means what here? That means what? We know that if sigma by omega epsilon ratio lies between what? 0.1 and 10. So then it is going to behave as what? It is going to behave as neither good conducting medium nor what? Nor good dielectric medium. Yes or no? So here we got sigma by omega epsilon ratio as 1.11. That means it is between what? It is between 0.1 and 10. So that means this medium is neither good conducting medium nor good dielectric medium. So in that case, what is beta here? What is beta for this type of medium? So the expression for beta is equal to what? Omega into square root of mu epsilon by 2 into square root of what? 1 plus sigma by omega epsilon whole square plus 1 whole to the power of 1 by 2. Okay. Okay. So I have already told here, how to determine this one. Yes or no? So this one I can represent it as what? Omega by c into square root of what? Square root of mu r epsilon r. Right? Okay. So what is this value? Tell me. I am calculating this value here. So this is equal to. So the frequency they have given as what? The frequency they have given as 10 megahertz. Right? Okay. The frequency is 10 megahertz, right? Okay. Okay. So the frequency is 10 megahertz, right? So that means I can write 2 pi into f. F value is 10 megahertz. So that is 10 into 10 power 6 divided by c. C value is 3 into 10 to the power of 8, right? Okay. And here so here they have given non-magnetic medium here. Non-magnetic medium means the relative permeability. The relative permeability mu r value is equal to 1. For a non-magnetic medium, relative permeability is equal to 1. And here they have not mentioned, and they have not given anything about what? Anything about relative permittivity. So we will consider relative permittivity is also equal to 1 here. We will assume epsilon r value is also equal to 1, right? Okay. Okay. So mu r value is 1 and epsilon r value also we are assuming it as 1. So then what you are going to get? Here 10 into 10 power 6, that is 10 power 7, and here 10 power 7 will get cancelled. So here you are going to we are going to have 10, right? Next, so 2 pi divided by 30 here. So you are having 2 pi divided by 30, right now? Okay, so 2 pi divided by 30. So this value is 0.2094, right? So this value. Next, calculate this value here. So sigma by omega epsilon value, sigma by omega epsilon value is how much? 1.11. Okay, so calculate this term here, calculate this value. What you are going to get, tell me? Substitute 1.11 here. So 1.11 square plus 1 under root, again plus 1, again under root. Okay, so you will get a 1.579. Okay, so this value is 0.2094. So beta is equal to 0.2094 into what? Into 1.579. So what is this value? Finally, this is equal to 1.579 into 0.2094. So you are going to get 0.3306 radian per meter, right? So this is beta value here. This is beta value. Okay. Oh yes. I forgot to take this root 2 here. Sorry. So here this value divided by what? This value divided by root 2. Okay. So that means here divided by root 2. So that means this is divided by root 2. Okay. Okay. 306 divided by root 2. So you will get, therefore beta is equal to 0.233 radian per meter. Okay. Okay. So beta value is equal to 0.233 radian per meter. So maybe in the yesterday calculations also, maybe I have missed somewhere root 2. Okay, I don't know, I don't remember that, but maybe here I am doing the mistake, means the same mistake I would have done yesterday also, I think so. Okay, so it is just a calculation mistake here that you can check, right? Okay, fine. So therefore propagation constant here, therefore propagation constant gamma is equal to what? Alpha value. What is alpha value we got? Sorry, we have already determined alpha value, right? So alpha value is 0.198. So alpha value is 0.198 plus J into beta value is 0.233. 0.233. Okay, meter inverse. So this is the propagation constant, right? This is alpha and this is beta. Okay, Selvaraj, thank you dear. Okay, so I hope this is correct here, calculation everything is correct, I think so, right? Okay, so next, so B, what they are asking here? Wavelength. So you can easily determine wavelength here. See, we know beta value now, we know beta value, yes or no? We know that beta is equal to 2 pi by lambda. So from here lambda is equal to what? Lambda is equal to 2 pi divided by beta. So just now we have determined beta value, that is 0.233, yes or no? So that is 2 pi divided by 0.233. So from here you can easily determine lambda value. So 2 pi divided by 0.233 is 26.9 966 meters. Okay. So this is wavelength. Right. Next, skin depth. So we know alpha value, so we can easily determine skin depth. So skin depth delta is equal to what? Skin depth delta is equal to 1 divided by alpha. So that is equal to 1 by 0.198, right? So 1 divided by 0.198. So this is equal to what? This is equal to 1 divided by 0.198 is 5.05 meters. So this is skin depth, right? And they are asking conductivity of the medium. So you can easily determine the conductivity of the medium here. Yes or no? So what is the conductivity of the medium? We have already determined sigma by omega epsilon ratio. So what we got? Sigma by omega epsilon ratio, we got it as 1.11. Yes or no here? Let us check. 1.11. Okay, I think we got 1.11 here. I think so. Right? Okay. So 1.11 sigma by omega epsilon ratio. So from here you can determine sigma equal to 1.11 into omega. Omega is 2 pi into f. F value is 10 megahertz. That is 10 into 10 power 6 into epsilon. Epsilon is epsilon naught into epsilon r. So epsilon naught value is 1 by 36 pi into 10 power minus 9. Epsilon r value we are considering it as 1 because they have not mentioned anything. So we assume epsilon r is equal to 1. Right. So now here 2 pi 1s and here 2 pi 18s, right, and here 10 power 7 and here 10 power minus 7 gone. So 10 power minus 2 will be left out, right. So therefore the conductivity of this medium is equal to what? Is equal to 1.11 into 10 to the power of minus 2 mho per meter or Siemens per meter, right. Okay. So this is conductivity of the medium. So we have determined all the parameters here. Yes or no? Okay. Yes. Right. Right here. So next problem. So write down next problem here. So third problem. A uniform plane wave in a lossy medium has a phase constant of 1.6 radian per meter, has a phase constant of 1.6 radian per meter at 10 to the power of 7 Hz. At 10 to the power of 7 Hz, and its magnitude is reduced by 60% for every 2 meters traveled. Then find the skin depth. Find the skin depth and speed of the wave. Find the skin depth and speed of the wave, right? So the first one, find the skin depth and speed of the wave, right? Okay, okay. Right. Okay. So what they have given here? Question. So a uniform plane wave in a lossy medium has a phase constant. Phase constant means beta r, has a phase constant of 1.6 radian per meter. So that is beta value is 1.6 radian per meter at frequency 10 to the power of 7 Hz. Yes or no? And its magnitude. So and its magnitude is reduced by 60%. Now its magnitude, or you can say amplitude or magnitude of the wave is reduced by what? Is reduced by 60% for every 2 meter. Is reduced by 60% for every 2 meter traveled. Then find the skin depth and speed of the wave. Then find the skin depth and speed of the wave. Tell me. A uniform plane wave in a lossy medium has phase constant of 1.6 radian per meter. So that means they have given beta value. Beta value is equal to 1.6 radian per meter. And they are saying that the magnitude will reduces by what? Reduces by 60% for every 2 meters. For every 2 meters. Right. So in that case, they are asking to determine the skin depth. Okay. So just follow the same procedure here. Just follow the same procedure. So just consider this as lossy medium, right? Okay. Follow the same procedure. So let us consider this as z-axis. So the initial amplitude, consider it as E0. So whenever the wave propagates in the lossy medium, the amplitude is going to decay exponentially, right? So that means this is E0 into what? E power minus alpha z. So they are saying that the magnitude, so that means this amplitude is reduces by 60% for every 2 meter. So if I assume E0 as the initial amplitude, so then after 2 meters, it has to be reduced by what? It has to be reduced by 60%. Yes or no? So 60% is reduced means what here? 40% of the initial amplitude will be present after 2 meters. Yes or no? So let us say this is this distance is 2 meters. Let us say this is 2 meters. So after traveling a distance of 2 meters, okay, so instead of drawing here, I can draw here. So after traveling a distance, z is equal to 2 meters, right? So its amplitude has become what? Has become 60% will be reduced for every 2 meters. Yes or no? Initial amplitude is E0. Now after traveling 2 meters, 60% will be reduced. So that means what is left out? Only 40% of the initial amplitude will be left out. So which means it is going to have what? 0.4 times of what? 0.4 times of E0. Yes or no? So this is nothing but 40% of its initial amplitude. Right, because 60% will be reduced, so only 40% will be left out after 2 meters, right? Okay, so that means at this location, so E0 into e power minus alpha z is equal to 2 meters here, z is equal to 2 meters. So after traveling a distance of z is equal to 2 meters, the amplitude will become equal to what? Will become equal to 0.4 times of what? 0.4 times of E0. Okay. Now the same thing here, E0 will get cancelled. So then apply ln on both sides. You are going to get minus alpha into 2 here is equal to ln of 0.4. Okay. Okay. So Selvaraj, skin depth 2.183 meters. Very good here. Very good. Very good. So ln of 0.4, you will get a minus 0.9162, right? And here minus alpha into 2. So minus minus will get cancelled. So therefore alpha is equal to what? Is equal to okay, you are going to get 0.458 Nepper per meter. So this is alpha value. Okay, and we know that the skin depth is nothing but what? The skin depth delta is equal to what? Delta is equal to 1 by alpha, which is equal to 1 by 0.458. So this is equal to what? So 2.183, approximately you will get 2.183 meters. So this is the skin depth here, 2.183. So very good here, very good Selvaraj, right? Okay, okay. .183 meters, right? Okay. So now they are asking what? They are asking phase velocity of the wave. We know that the phase velocity of the wave is equal to what? Is equal to omega by beta, right? So they have given already beta value here. So what is beta value? So beta is 1.6 radian per meter, and also they have given the frequency. The frequency is 10 power 7 Hz, right? Okay. So now okay. So omega 2 pi f. F is 10 power 7. Beta value is 1.6 now. 1.6. 1.6, right? So beta value is 1.6. So it is a simple question here. 1.6. Substitute 1.6. That's it. Okay. Okay. So 2 pi divided by 1.6. So you are going to get 3.92 into 10 to the power of 7 meters per second, right? Okay, very good Selvaraj, right? Okay, yeah. Okay, see in the same problem here, see here we got a alpha value is equal to what? Alpha value is equal to 0.458 Nepper per meter, right? And beta value is equal to what? 1.6 radian per meter, right? Okay, okay, yeah. So now see here. Now if suppose in the same problem, if suppose they have asked determine what here? To determine loss tangent. Tell me what is loss tangent here for this problem. In the same problem, if they have asked to determine the loss tangent, so that is sigma by omega epsilon ratio. So what is this value? Tell me here. In the same problem, if they ask to determine sigma by omega epsilon ratio, how you will determine? Tell me. What is sigma by omega epsilon ratio? Tell me. Tell me, Selvaraj. Tell me what is sigma by omega epsilon ratio. Determine loss tangent and tell me the answer. What you are asking? Give more difficult problems. Okay, okay, dear. If you are ready, I am also ready to give more and more difficult problems, right? Okay, okay. Determine sigma by omega epsilon ratio. ratio of alpha and beta. What is ratio of alpha and beta? Do ratio of alpha by beta will give you sigma by omega epsilon ratio? Do alpha by beta will give you sigma by omega epsilon ratio? This is what you are saying? Selvaraj, do alpha by beta ratio will give you sigma by omega epsilon? Tell me here. Are you saying this one? Apply the formula. What formula? Alpha by beta is not sigma by omega epsilon, right? Okay. See, already the same type of problem here. Whenever you know alpha and beta values, I have already told how to determine sigma by omega epsilon ratio. Yes or no? See, if you know alpha and beta values, how to determine sigma by omega epsilon ratio here? Tell me. Tell me. I have already given one problem also, right? See here, gamma is equal to alpha plus j beta, right? Okay. And for lossy medium, this gamma is equal to what? Square root of j omega mu into sigma plus j omega epsilon. So if you square on both sides, you are going to get alpha square minus beta square plus j into 2 alpha beta, which is equal to j omega mu into sigma plus j omega epsilon. So here you are going to get what? J omega mu sigma minus omega square mu epsilon. So here alpha square minus beta square plus what? Plus j into 2 alpha beta. So now comparing the real parts on both sides. If you compare the real parts on both sides, what you are going to get? Alpha square minus beta square is equal to minus omega square mu epsilon. So this implies beta square minus alpha square is equal to what? Omega square mu epsilon. Next, if you compare the imaginary parts, you are going to get what? 2 alpha beta is equal to what? Is equal to omega mu sigma, right? So therefore 2 alpha beta is equal to omega into mu sigma. So from this here, from this, okay, so if you take a 2 alpha beta divided by what? Divided by beta square minus alpha square, what you are going to get? Omega mu sigma divided by omega square mu epsilon, you are going to get what? Sigma by omega epsilon, right? So I also told that remember this formula, right? If you know alpha and beta values, then you can determine what? You can determine sigma by omega epsilon ratio. Okay. So therefore sigma by omega epsilon is equal to what? 2 into alpha value. Substitute alpha value and beta values here. So what is alpha value? 0.458 and 1.6. 0.458 into what? Into 1.6 divided by 1.6 whole square minus 0.458 whole square. So this is going to give you sigma by omega epsilon ratio, right? Okay, you can calculate this one here. Yes or no? Not needed. Selvaraj, not needed to apply the formula for alpha and beta. See here, this is very simple or not? I have already given one problem based on this also. I have given only alpha and beta values. That means I have given only propagation constant value and I have asked you to determine the loss tangent, right? So you can remember directly this one as formula here. So you can remember this one as formula, right? Okay, in a lossy medium, if you know alpha and beta values, you can determine sigma by omega epsilon ratio, right? So this is loss tangent, yes or no? Loss tangent, or we can call this as sigma by omega epsilon ratio. Yes. Right. Okay. Yeah. So what is this value you got? Tell me. What is the value you are going to get? Tell me. So this value you will get 2.35, and in the numerator what you will get? So 2 into 0.458 into 1.6. Okay, that is 1.4656. Okay, so this divided by 2.35. So you are going to get 0.623 here. You are going to get 0.623. So this is the last tangent, right? Okay. So 0.623 means it is greater than 0.1. Yes or no? So here sigma by omega epsilon ratio is lying between what? 0.1 and 10. 0.6 means it is greater than 0.1. Right. So that means the medium is what? The medium is neither good conducting medium nor what? Nor good dielectric medium. Right? Because it is lying between 0.1 and 10. Right? Okay. So next problem here. Next problem. Next problem, write down. Okay. So next problem here. So this is gate problem. This is previous gate problem, right? Okay. So write down here. So this is fourth problem now. For today it is fourth problem. The distance in meters. The distance in meters. A wave has to propagate. A wave has to propagate. A wave has to propagate in a medium. The distance in meters a wave has to propagate in a medium having a skin depth of 0.1 meters, having a skin depth of 0.1 meters, so that the amplitude of the wave attenuates by 20 dB. Attenuates by 20 dB is tell me here. The distance in meters a wave has to propagate in a medium having a skin depth of 0.1 meters, so that the amplitude of the wave attenuates by 20 dB is, right? Tell me here. So the distance in meters a wave has to propagate in a medium having a skin depth of 0.1 meters, so that the amplitude of the wave attenuates by 20 dB. So here the attenuation, the overall attenuation they have given in terms of what? In terms of dB. So that is 20 dB. right? So in this case, how we can solve the problem, right? Okay, okay, yeah. So see here, I will explain two methods here for this one. So the first one, so they have given the skin depth delta is equal to 0.1 meters and the attenuation they have given as 20 dB, right? Delta is equal to 0.1 meters and the attenuation they have given as 20 dB, right? Okay, yeah. So now see here. Now see here. So they are saying that the amplitude of the wave attenuates by 20 dB, right? So now we know that whenever the wave is propagating in a lossy medium, so its amplitude is represented by what? Is represented by E naught into e power minus alpha z. Yes or no? So let us say it is propagating in z direction. So its initial amplitude, let us say E naught. Now this is some lossy medium. So as it propagates, the amplitude is going to decay exponentially. So that is E naught into e power minus alpha z, right? Okay, okay, yeah. So E naught into e power minus alpha z, right? Okay, yeah. So now see here, forget about this dB and all. We know that whenever the wave is propagating in this lossy medium, its amplitude is going to decay. Its amplitude is going to decay, right? Okay. So now let us assume after traveling z meters here, let us assume its amplitude is attenuated to E naught by k here, E naught by k. So where k is greater than 1, Understood? So that means its amplitude attenuated by this factor here, okay, or I can call this as attenuating factor, right? Okay. So after traveling some z meters, its amplitude has become what? E naught by k. So it has attenuated by k times, where k is greater than 1. Understood? Okay, okay, yeah. Right, okay. So now see here. Now if I apply log on both sides here, or if suppose see here E naught into e power minus alpha z. So here e power minus alpha z is nothing but what? It is nothing but attenuating factor. Yes or no? It is nothing but attenuating factor, right? So here on both sides this E naught will get cancelled. So this attenuating factor e power minus alpha z, I can write it as what? 1 by k, right? Now if I apply 20 log on both sides here, so then I am going to get 20 log of e power minus alpha z into what? Is equal to what? Is equal to 20 into log of what? Log of 1 by k. So 1 by k means I can write k power minus 1. So this is equal to minus 20 into what? Minus 20 into log of what? Minus 20 into log of k, right? Okay. So 20 into log of e power minus alpha z is equal to what? Is equal to minus 20 into log of k. So now see here, they have given the attenuation, the overall attenuation they have given as what? 20 dB. So that means here k is nothing but what? K is nothing but attenuating factor. So 20 into log of k is nothing but the attenuation in dB. Yes or no? Now this represents what? This represents attenuation. This represents the attenuation in what? In dB. So what is the attenuation in dB they have given? That is nothing but 20. Yes or no? So now substitute here 20 here. So this is equal to what? Here you are having minus, and here 20 log k attenuation in dB they have given it as 20 dB. Yes or no? 20 dB, right? Okay. So that is 20. You can write simply 20. So 20 dB. So this is equal to what? This is equal to 20 into log of what? Log of e power minus alpha z. So here 20 will get cancelled. So I can write this as what? E power minus alpha z is equal to what? 10 power minus 1. So now if I apply ln on both sides here, what you are going to get? Minus alpha z is equal to what? Ln of 0.1, right? Okay, yeah. So therefore alpha minus alpha z is equal to ln of 0.1 is nothing but minus 2.332, right? Ln of 0.1 is 2.302 here, 2.302. So minus minus will get cancelled. So therefore z is equal to what? Z is equal to 2.302 divided by alpha. So 1 by alpha is nothing but what? Delta. Yes or no? So I can write this as 2.302 into 1 by alpha is nothing but delta. So skin depth they have given as 0.1 meter. So substitute 0.1 here. So what you are going to get finally? So 0.23 meters. Right? Okay. So z value is equal to 0.23 meters. Right? Okay. Okay. So therefore z value is equal to 0.23 meters. Right? Okay. So the distance it has propagated is what here? Is z is equal to what? Z is equal to 0.23 meters. 0.23 meters. So this is the distance it has propagated, right? So this is the answer for this question. See the same question here, the same question I can answer in a very very simple manner. See here, so without doing all this here, without doing all this, in a very simple manner I can solve this problem. So how I can solve this problem here is, see here, so that is second method here. Let us say this is second method, right? Okay. See, we know how to convert dB into Nepper and Nepper into dB. So that is the relation is 1 Nepper is equal to what? Is equal to 8.68 dB here. 1 Nepper is equal to 8.68 dB. So therefore 1 dB is equal to what? 1 by 8.68 Nepper. 1 dB is equal to 1 by 8.68 Nepper. So here they have given the overall attenuation as 20 dB. So I can convert this 20 dB into what? Into Nepper. So 20 dB is equal to what? Is equal to 20 divided by 8.68 Neppers. Yes or no? So this is equal to what? This is equal to, so 20 divided by 8.68. So 20 divided by 8.68 is equal to what? Is equal to 2.304 Nepper, right? So 20 dB is equivalent to what? Is equivalent to 2.304 Nepper, right? See, we know that alpha represents what here? Alpha represents attenuation constant. It is the attenuation constant. Yes or no? It is attenuation constant. So it represents what? It represents the attenuation of the wave per meter. Yes or no? So it represents attenuation per what? Per meter. Attenuation per meter. How the amplitude of the wave attenuates for every meter. So that is given by attenuation constant. Yes or no? So it represents attenuation per meter. Suppose now the wave has travelled z meters here. If the wave has travelled z meters, then what is the overall attenuation? So alpha represents attenuation per meter. If the wave propagates z meters, then what is the overall attenuation? So the overall attenuation, if the wave propagates, by z meters, if the wave propagates by z meters, okay, then overall attenuation, is given by what? Is given by what? Alpha into z. Yes or no here? Alpha represents attenuation per meter, alpha into z represents the attenuation over z meters. Understood? So here the units of alpha is nothing but Nepper per meter, and the units of z is nothing but meter. Right? So the overall attenuation, the units are nothing but what? Nepper. So here they have given the overall attenuation in Neppers is nothing but what? Is nothing but 2.304. So 20 dB means it is equivalent to what? It is equivalent to 2.304 Neppers. So this overall attenuation in Neppers is equal to what? Is equal to 2.304. Understood? So therefore from here z is equal to what? Z is equal to 2.304 divided by alpha. So this is equal to 2.304 into what? 1 by alpha. So that is nothing but delta. So this delta value they have given as 0.1. So that is equal to what? That is equal to 0.23 meters. Yes or no? So this is another method here. So it is very simple or not? Okay. So without doing all those calculations, we can directly determine here. So just you have to convert this dB into Nepper. Then you are going to get the overall attenuation over Z meters. So the overall attenuation over Z meters, we can represent it as alpha Z. So that is equal to 2.304 Neppers. That is equal to 2.304 Neppers. Yes or no? So from this you can determine the Z value, the distance it has traveled. So that is equal to 2.304 divided by alpha. 1 by alpha is delta. So delta value, that is skin depth value, they have given as 0.1. So if you multiply with 0.1, you are going to get 0.23 meters. So the same thing or not? Yes or no? 0.23 meters. The same answer you are getting or not? Okay? Okay. Right? So I hope it is crystal clear here. Is there any doubts here? Is there any doubts? Selvaraj? Tell me. Is this clear? Is this problem clear? Tell me here, if you are having any doubts, what you are not able to understand sign, which one here? The second method or first method? Selvaraj, second method or first method? So here I have applied 20 log on both sides here. I have applied 20 log on both sides. So what you are going to get? 20 into log of e power minus alpha z is equal to what? 20 into log of 1 by k, I can write it as what? K power minus 1 or not? Yes or no here? 1 by k I can write it as k power minus 1. So that means I can write it as what? Minus 20 log k. Yes or no here? Twenty log k power minus 1, I can write it as what? Minus 20 log k. Right? So now this is attenuation in dB. So the attenuation in dB is nothing but 20. So here you are having minus sign. Okay. Wait. Okay. Oh, sorry. Yes. Okay. So if you are having right. Okay. See, I can say in this manner. See here, 20 log of 1 by k okay. So this I can write it as 20 log of 1 minus what? Minus 20 log k. Yes or no? Log 1 is 0. So this value will be 0. So what you are having? Minus 20 log k. See, can I write in this manner here? 20 log of 1 by k, I can write it as what? 20 log of 1 minus 20 log k. So 20 log 1 is 0. So what is left out? Minus 20 log k, right? K equal to e power minus alpha z. No, here I have substituted here 1 by k, right? So 1 by k I can write it as what? This 1 by k I am writing it as k power minus 1, right? So k power minus 1, so I can write it as what? Minus 20 log k. So what is your doubt here? What is your doubt? Yes, here on this side it is attenuating factor. So after attenuation the amplitude will reduce or not? So that reduction I have written it as what? E naught by k, where that's why I have represented here k greater than 1, right? Right? Okay. K equal to exponential e power minus alpha z. What you are saying here? Is it clear? Yes? Okay. Okay. So if you are having any doubt here, you can simply follow this method here. You can simply follow this method. It is very, very simple, right? So follow the second method. It is going to be very, very simple without any confusion, right? Okay. So follow this one here. If you are having any doubt, you can follow this method. Right? Okay. So okay here. So I hope this is crystal clear. So with this I am winding up the session for today. So tomorrow we'll meet exactly at 7:30 p.m. Okay. So EMT class will be conducted exactly at 7:30 p.m. tomorrow in our Gate Academy Global channel, right? Okay. So tomorrow, if possible, if I find some new problems based on this, I will take that one. Otherwise, I am planning to start a pointing theorem here. We try to solve some problems based on what? Pointing theorem, right? Okay. Okay. So in tomorrow's class, most probably we'll try to solve the problems based on what? Based on pointing theorem. So we try to learn the concept of this pointing theorem through problems, right? Okay. Okay. So with this, I am winding up the session for today, right? So tomorrow we will meet exactly at 7:30 p.m. So okay then, take care, bye bye.